we are going to start multiplying rational expressions, and then we're going to divide rational expressions. We're going to be working a lot with these algebraic fractions. But first, let's go back to elementary school. Remember how you used to multiply fractions. 2 times 5 is 10. You multiply the numerators together, the tops, and then 3 times 7 is 21. You multiply the bottoms. Sometimes, when you have fractions like this, 2/5 times 3 over 2, 2. You notice that when you have a number up there and a number down there, and they're the same number, they cancel out. So you're left with a 3 on top and a 5 on the bottom. Okay, so we're going to be using those old rules, but now we're using them with algebra. Here we go. And the easiest way to do this, I think, before you multiply anything, is to factor. Okay, I'm going to do that. So I'll have y to the 7th over 4 parentheses y plus 4, 4y plus 16 equals 4 times y plus 4 in parentheses, times 5y plus 20 is 5 times y plus 4 over 5 y to the 9th. Now, obviously, some of these are going to cancel with some of those, but let's leave that for a few minutes. Everything now, except for these guys, is factored. Notice your 5s now cancel. The y plus 4s cancel. And now what you're left with is y to the 7th power on top over 4 times y to the 9th. Now, rather than making all those y's like we did yesterday, or the day before, whenever it was we did it, I guess yesterday, what I want to do is use those rules, right? Those rules of exponents. So that will take y to the 7 minus 9 over 4, because here we have like bases. Although I do want to erase that little thing in the middle. There, all right. All right, here you have a y base, here you have a y base. So when you divide y bases, you write the base, and then you subtract the exponents. So our answer will be y to the negative 2 over 4. Now that might not be so bad, except there's a rule in algebra that you don't leave an answer with a negative exponent. So we have to translate. Y to the negative 2 wants to come down here and become y to the positive 2. So our final answer will have a 4y to the positive 2 on the bottom. And up here, do not put a 0. We put a 1. That's your final answer. Of course, you could have made 7 y's here and 9 y's there. 7 of them would have canceled out. You would have been left with y to the 2 down here. So, same thing. This is just quicker. Any questions? Just pop right on up. There's a kind of a motto you could say to yourself, that the way we do these problems is factor, cancel, or factor, factor, cancel, cancel. Was someone going to say something? Okay, then on we go. 64 is 8 squared. So this will be x squared minus 8 squared. I'll be factoring that by the difference of 2 squares. Here we have x squared minus 8x. X squared is x times x minus 8x. Now, just a minute here. There you go, Hayden. I'm going to mute you because something is squeaking. Doesn't mean it's you. Feedback from somewhere. Okay, down here we have a quadratic trinomial, and if I can factor negative 80 into factors that add up to positive 2, then I'll be able to factor that as well. And since negative 80 equals negative 8 times positive 10, because I know 80 equals 8 times 10, and if I say 10 minus 8, that's 2. So sometimes these things occur to you and you don't have to do the whole factorization. Negative 8 plus 10 is positive 2. So our factorization is going to use those two numbers. All right, so let's get to work. X squared minus 8 squared is x 8 plus minus. X squared, shoot, that's easy. I mean, it's short, right? It's just x times x, so I'm going to write it that way. It's not like it's 9 or 10 x's. Ugh. Okay, here we have x times x minus 8x. Our GCF will be x. And the leftovers will be x minus 8. And down here, we'll have x times x and minus 8 and plus 10. Okay, and now we have factored both fractions, both rational expressions. Or you could think of them as being two different functions. Maybe f of x, here's a little review, f of x equals x squared minus 64 over x squared, and g of x, maybe, equals x squared minus 8x over x squared plus 2x minus 80. Remember when we did that unit on function arithmetic? What we're doing here is fg, or f times g, of x. In other words, we're going to multiply f of x times g of x. This whole problem could have been written that way, but it wasn't. So you can be grateful. All right, here we go. Now, x minus 8 will cancel x minus 8. Notice you can cancel inside the same fraction. Or I could have canceled x minus 8 with that x minus 8. It doesn't matter. And this x will cancel with that x. And look what I'm left with. X plus 8 times x minus 8. Because there was only one x minus 8 on the bottom, I could cancel it either with that one or with that one, but not with both. On the bottom, I have one little x left. And I have a binomial factor, x plus 10. And we cannot factor anything else. So the most common way to answer is to leave everything in factored form and not multiply it all back together. Because after all, there was a reason that you multiplied and simplified. All the factoring is called simplifying. And of course, we're multiplying as well. But actually, it's more simplifying than multiplying. Notice how important factoring is for this.
Miss?
Yes.
Where did you cancel the x on the left with? What did you cancel it with? The x at the bottom, at the left?
Yes,
yeah.
With that.
Oh, okay.
Thank you for asking. Maybe I should circle them. Kind of hook them up together like that. That's a good idea. At least it puts a little color in there. Good, any more questions about what we did here? This is factoring by the difference of two squares. This is factoring by GCF. So this is difference of squares. This is GCF. And this is just factoring a trinomial, a quadratic trinomial when A equals 1, because A over here equaled 1. So I'm just going to put A equals 1 method. Rather than spending all my time writing the names of these methods, which are already in your notes. All right, let me put a box around this. Okay, see the goal? One of your goals in life should be Nah, that's too much, isn't it? Yeah. Okay, one of your goals in life should be to recognize these different factoring methods quickly. For instance, y squared minus 25, I know is y squared minus 5 squared. So I'll be factoring that by the difference of two squares. Y plus 6, I can't factor that. Y minus 5, nothing to factor there. But here, I have a GCF. 7 times y plus 7 times 6. So 7 will be our GCF. So this is how I'm going to rewrite this. All right, y, 5, 5, plus, minus. I've taken care of this. Now down below it, 7 parentheses, y plus 6 times y plus 6 over y minus 5. And the reason I'm putting parentheses around this is there are parentheses over here, and to not have them over here could be confusing. It depends on you. All right, let's start canceling. Y minus 5 and y minus 5 will cancel. Y plus 6 and y plus 6 will cancel, leaving me with a y plus 5 on top and a 7 on the bottom. And that would be my answer. See, I like it when I get to cancel almost everything, and then this is my answer. When I have answers like this, where look, not a whole lot canceled, I just feel kind of like unfulfilled. Okay, now here's a nasty looking one. Woo. Okay. Let's do these separately. Y squared minus 3y minus 54. Okay, negative, well, let's do positive 54 first. I already know what it is. Okay, 54 equals 6 times 9. Negative 54 equals negative 6 times positive 9. It also equals positive 6 times negative 9. But look at this. I'm looking for a negative 3. Well, negative 6 plus 9 equals positive 3. Positive 6 plus negative 9 is really negative 3. So these are the two numbers I'm going to use. Why don't I go up here right now and take care of that before I forget? All right, parentheses. See, y is 1 here. So we're using the a equals 1 method. Y, positive 6, so plus 6, negative 9, so minus 9. Now let's work on this. 6y to the third minus 5y squared is 6 times y times y times y minus 5 times y times y. And both of these terms contain two y's, a y times y. That's my GCF. I pull it out to the front, y times y is y squared. And then I'm going to be left with 6y minus 5. So I will write that up here, y squared times 6y minus 5. Now I'm ignoring the phone. Should have put it on Do Not Disturb. Yesterday I put it on, I turned off my phone, completely forgot, left it off all night. So I didn't exactly grieve about that. All right, so let's look at this. We have a 36, which is 6 times 6, times y times y times y, minus 25 times y, that's 5 times 5. So this is 6 times 6, this is 5 times 5. All that these terms, the only thing these terms have in common is a y and a y. Right there. So this will be y times 36y squared minus 25. Ah, but there's more to do on that. 36 is a perfect square. Y is a perfect square. 25 is a perfect square. So another way to write this is 6y in parentheses squared minus 5 squared, parentheses. So now I can factor the leftovers in here by the difference of two squares. So that will be y times, and then this is going to factor into two sets of parentheses. 6y and 6y, and 5 and 5, and plus and minus. Excuse me. So, whoo, there was quite a lot to that one. Let me go write that. Now, where's that? That's up here. So y, scroll it up a little bit. There we go, I'm looking down here. Y times 6y plus 5 times 6y minus 5. I can already see that, and that will cancel. And 9y minus 81. 81 is a perfect square, but that's not a perfect square. 9y minus 81 is going to be 9 times y minus 9 times 9. Both terms contain a positive 9. So I'll factor this by GCF. 9 times y minus 9. 9 times y minus 9. And while I'm at it, I'm going to, I'm going to change my y squared to y times y, because why? It'll just be more convenient. If I do that, then, and I think I'll choose a color to do this, it will be much easier to cancel those two y's. This y and that y will cancel. 6y minus 5 will cancel with 6y minus 5. And y minus 9 will cancel with y minus 9. Leaving me with, I have a y plus 6 and a 6y plus 5. Over a 9 and a y. There you go. And we were still able to cancel a good bit. Discussion. Yeah, that's kind of awesome, isn't it? Okay, next is divide. So now is a good opportunity to ask any questions you might have had about multiplying rational expressions or multiplying rational functions. Factor, factor, cancel, cancel. Okay. You can see that the trick to all this is factoring. All right, another blast from the past is called for. I'm going to use the same fractions I used before, but instead of multiplying, I'm going to divide. Okay. Now, if you recall from way, way back, you write the first fraction just the way it is. You change the division sign to multiplication. And you take the reciprocal of the second fraction, 7/5. Well, that's all there is to it. Then you multiply. 2 times 7 is 14. 3 times 5 is 15. So the whole idea really is that since you would have mastered multiplication first, you're able with division to turn it into a multiplication problem. All right, that's what we're going to do. So I choose, before I do any factoring, to do these steps first. X squared plus 5x plus 4, where a equals 1. So we'll factor this by a equals 1. The a equals 1 method. Here, 4x minus 16. We'll factor that by GCF. Times x minus 4 goes up. Can't factor that. And x squared minus 3x minus 4 goes down. And I'm going to use the a equals 1 method here. So now I'm ready to start factoring. So x squared plus 5x plus 4. Okay, 4 equals 1 times 4. And 1 plus 4 equals 5. So the numbers we're going to use are, might as well make a notation, positive 1 and positive 4. For x minus, oh, I don't want to do it that close. Where's my eraser? There was an upgrade. I actually spent half an hour just practicing on the new version because it's so different. 4x minus 16 is 4 times x minus 4 times 4. Both terms contain a positive 4. So 4 is the GCF. And the leftovers are x minus 4. Okay. I really should be doing this as I go along. That would be better. X plus 1 times x plus 4 over 4 times x minus 4. Okay, and then I'll put a times there. And now x squared, well, still, x squared minus 3x minus 4. Now, 4 equals 1 times 4. So I shouldn't be putting that equals there yet, but I'll just come down here. 4 equals 1 times 4. But negative 4 equals negative 1 times positive 4, and positive 1 times negative 4. And if I add positive 1 plus negative 4, I will get negative 3. Okay, so now I know how to factor this. I am going to use the numbers positive 1 and negative 4. So now, x minus 4 is up. And x positive 1 plus 1, should put a plus in front of there, plus 1 and minus 4. And there we go. There's our completely factored problem. And now I just have to decide. Big decision here. I've got an x minus 4 and an x minus 4. I can cancel that way. Or an x minus 4 and an x minus 4. I can cancel that way. Well, actually, I can see a very good reason to cancel this way. Namely, x plus 1 will cancel with x plus 1. And this second fraction is going to be wiped out. So my final answer is going to be x plus 4 on top over 4 times x minus 4. I have found that, just speaking for myself, I make fewer mistakes if I go ahead and do this step, change the division sign to a multiplication sign, and then flip the second fraction. I personally make fewer mistakes if I do that first and then do my factoring. But you'll find out as you go along which methods are better for you. Well, that was so much fun. Let's do another. Well, this looks easier. I mean, at least there aren't as many terms, are there? Just for your benefit, just so you'll know, this is a monomial. This is a monomial. This is a monomial. And this is a monomial. A polynomial with only one term is called a monomial, which automatically makes it easier, maybe. Well, let's find out. 12x to the 5th over 3y to the 9th times 6y to the 3rd over 16x squared. Okay. I'm just going to break everything down and cancel. Kind of going through different methods, I could say 3 into 12 is 4, and that 4 into 16 is 4. Meanwhile, 2 goes into 6 and 2 goes into 4, and all of that. I could do that, and I've done it in the past, and it's so confusing to see what's left and what still has to go, because you've got these cancel marks all over the place. It's cleaner just to do this. So I'm going to put 12 up here. I'm going to change 12 to 3 times 4. And, well, I don't know. What the heck? 1, 2, 3, 4, 5. Why not? Over 3 y to the 9th. Yuck. Okay. Y 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe that wasn't a good idea to do that with the x's and y's. Okay, 6 times y times y times y over, no, that's going to be 2 times 3. Two times 3 over 4. If I say 4 times 2, I mean, if I say 4 times 4, well, that's still not so bad, but let's say 4 times 2 times 2. 2 times 2 is 4, 16 is 4 times 4. Okay, now, the value of this is I can cancel this 2 with one of those 2's. I can cancel the 4 with the 4. I can cancel the 3 with the 3. I can cancel, oops, forgot the x's, there they are. So cancel an x, cancel an x, cancel an x, cancel an x, cancel a y, 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 and then, no, if I had to do it over again, I'd use the rules of exponents. But I'm already half done, more than half done. This is, all that's left up here is x to the third. All that's left over here is a 3. So I'll have 3x to the third over y times y, 1, 2, 3, 4, 5, 6. Y to the 6. And a 2, yes?
Where did the 3 come from in front of the x to the third? Isn't like supposed to be like x to the third alone?
Yeah, it's right there.
Okay.
Yes. Thank you, though. Thank you. See, it's still difficult to see. 3 and 3, yeah, that 3 right there. And this 2 is going to go in front of y to the 6th. And x and y are different bases, so I can't subtract the exponents. Let's see what would happen if I had used the rules of exponents. 3 times 4 times x to the 5th over 3 y to the 9th times 2 times 3, I am going to do that, y to the 3rd over 16, which is 4 times 4. I'll just leave it that way, times x squared. If we take care of the numbers first, 3 and 3, 4 and 4, and 2 goes into 4 2 times. So I'm going to put a 2 right there. Then I'll be left, for the moment, this is not the final answer, to the 3rd and the 3 over 2 times x squared y to the 9th. Okay, now much better, much cleaner. All right, this is what we've got. We've got a 3 here and a 2 here. X to the 5th over x to the 2 is x to the 5 minus 2. And y to the 3rd over y to the 9th is y to the 3 minus 9. So that will be 3 over 2. X to the 3rd, y to the negative 6 And one more step. This is so much cleaner doing it this way. The difficulty is what happens if you don't always remember the rules of exponents. Then you really have to switch to that method. I like this better. I just wanted to see which method would be easier to read. Maybe it'll help you too, maybe. Let me put a line between these. Here's a small.
Just go back up 1 second.
Yes, yes, going back. Yes.
Right, write that off real quick.
Okay.
Okay, thank you.
You're welcome. Okay, here we go. 6z plus 18 over z times z over z plus 3. This is going to be so easy. Disappointed. This is the only thing we have to factor. 18 is 6 times 3, so there will be a GCF of 6 right there. So this is going to be 6 times z plus 3 over z times c over z plus 3. And now the z's cancel, the z plus 3's cancel, and all I'm left with is a 6. Well, okay. Occasionally you get a problem like that. If there had been a 6 down here so the 6's would cancel, so that everything canceled, the answer would be 1. Okay. Now, I'm sure you get the idea by now, but yeah, that's the end of the problems. This one is not going to be so difficult. This one, though, looks like it could be a little annoying. Let's do this one. Okay, y cubed plus 7y over y squared minus 49 times y squared plus 2y minus 63 over y squared plus 5y minus 36. Okay, so thinking strategy first. I know that y squared is y times y times y. So both of these terms contain a y. I'll be factoring this by GCF. y squared minus 49 is going to be factored by the difference of squares because 49 is 7 squared. So this is going to be diff of squares. Or, if you prefer, diff of squares. Now, both of these are trinomials in which a equals 1. So I'm going to factor both of these by the a equals 1 method. And now that I have it kind of worked out in my head, let's go ahead and do our factoring down here. Y to the third plus 7y equals y times y times y minus 7y. Both terms contain a y, so that will be our GCF. Y times y is y squared. We'll have y squared minus 7. And y squared minus 49 is y squared minus 7 squared. So it factors into y and 7 and plus and minus. The other two are a little more difficult. I'm going to use this first. Y squared plus 2y minus 63. Okay, 63 equals 9 times 7. So negative 63 will equal negative 9 times positive 7, or positive 9 times negative 7. I could have just put an equals there. It's both. Okay, now 9 plus negative 7 is really 9 minus 7. Let me come up here because I need the room. 9 plus negative 7 is 2. Okay, it's really 9 minus 7. There. Okay. So yeah, we're going to factor this. Factor this by, these are the numbers we're going to use. 9 and negative 7. I'm going to write them here. 9 and negative 7. Okay, and this one, y squared plus 5y minus 36. Okay, 36 is 4 times 9. Negative 36 is negative 4 times positive 9, or positive 4 times negative 9, but if you add negative 4 plus positive 9, that will give you positive 5, which is what you've got right there. So we are going to use negative 4 and positive 9. Kind of getting the strategy together. Okay, so it's kind of sweating it here. Don't have much room left. Maybe. Nah, come on, let's try it. Let's be brave. Y times y squared minus 7 over y plus 7 times y minus 7. These look almost alike, but the fact that that's a y squared and that's a y means that this set of parentheses is not exactly like that set of parentheses, so I can't cancel them. Wouldn't you know? Okay, we'll have a y and a y. And now, y squared plus 2y minus 63, I'll be using positive 9 and negative 7. So plus 9 minus 7 over y, okay, negative 4 and positive 9, minus 4. And plus 9. And there is our factoring, and I go back over it just to make sure. Looking. 9 times 7, so that'll be 9 times negative 7. Oh, no, yeah, 9 times negative 7, yes. And 4 times 9, so 36, there you go. 9 minus 4 is 5, yes. Okay, this is right. Maybe I shouldn't have checked, almost got myself messed up. So here's y plus 9. We'll let it cancel y plus 9. Y minus 7 cancels y minus 7. And that's all there is. So we're still going to have a pretty big answer. Y times y squared minus 7 over y plus 7 times y minus 4. How's that look? First, I changed this to multiplying by the reciprocal of the second fraction. Then I looked at the top, the bottom, the top, the bottom, and figured out my strategy before going into it. And I think that made things easier, helping me to kind of work out in my mind what I was going to do.
So Miss, if you wrote for the second fraction, if you wrote 1 over y minus 4, would that be wrong?
Yes, it wouldn't be simplifying.
Okay.
Because just getting them from two fractions into one fraction is a form of simplifying.
Oh, okay.
But that is a good question. Because you're right, technically it would not be wrong, it just would not be completely simplifying. All right, one more. We've got time for one more. We can get this guy out of the way. 36 c squared minus 25 over c squared minus 16 times c minus 4 over 6c minus 5. All right, 36c squared minus 25. These guys are perfect squares. This is 36c in no, it's not. I'm lying to you. What a bad teacher. Okay, 6c squared, like that, minus 5 squared That's what that is. And then that will let me factor by the difference of squares. So I'll have 6c, 5, 5 plus minus c squared minus 16 is a definite factorization by the difference of squares. C, 4 plus minus. C minus 4, nothing you can do with that. 6c minus 5, there is no GCF. And it's not a quadratic, so no, you can't factor this at all. So now I'm going to go back up here and write 36c squared as that 6c plus 5 times 6c minus 5 over that c plus 4 times c minus 4 times c minus 4 over 6c minus 5. And now I'm going to cancel. C minus 4 cancels with C minus 4. 6C minus 5 cancels with 6C minus 5. And so our final answer is 6C plus 5 over C plus 4. Ta-da! And I should have put a box around the others. Six. Can you believe that? Here, whichever method you use, that's your answer, but it is tricky because it's hard to see little leftover numbers. Maybe circling would help. I don't know. And then here, blast from the past, no. Now, straight multiplication, you're not going to flip anything. You're just going to factor and cancel. Factor, factor, cancel, cancel. There.